the first collections are those number, I said number 4, yes? That was the number 4. You want to find the exact value, was number 4. So that is, okay, that is going to be our practice. Okay, practice test, number 2. Okay, practice test number 2, and this is number 4, I think that was the one. Okay, you want to find the exact value. We give you 2 questions of this group. There are 2 types, we put them together. Okay, something like 4 cases. Find the exact value of each expression. So this means you are not going to use your calculator, remember. You can use the table, but not the calculator. Okay, there you are. The first one. We want to find the sine inverse of radical 2 over 2. You want to find an angle whose sine is radical 2 over 2. You can get it. It's going to be
P over 4.
P over 4, yeah, pi 4. But this is the official version, if you like. The sine inverse of radical 2 over 2 is theta. You switch it. The sine of theta is equal to the radical 2 over 2 with the restriction that the theta must be between pi half and the pi half for the sine. You want an angle whose sine is radical 2 over 2. That angle is pi 4. And we're done. Okay, even if you write the pi 4, we accept it. So the sine inverse, when it's a radical negative numbers, you got to be careful. But we accept the pi 4 right away. Any question? You must have only one solution. Remember, it's a unique solution. That's the case 1. Any question? You may have it with the cosine. It's a negative number, it's a red flag. Be careful. You want to find a function, and we want to find an angle whose sine is negative 1/2. Switch it first. Okay, so the solution is cosine inverse of negative 1/2. Call it theta. Okay, so the cosine of theta is equal to the negative 1/2. And remind yourself that you must be in the first or the second quadrant. Cosine is negative, it's the second quadrant. Use the table to find an angle whose cosine is 1/2. Have that angle if you use your table that just want to show you. Okay, you see you are in the second quadrant and you want to find the cosine. Cosine is first component. So this is going to be 120 degrees or 2 pi third. Okay, so the theta is going to be equal to the 2 pi third. Double check, make sure you get it right. And so, if you like, this is it, it's correct. You do that. Cosine inverse of negative 1/2 is equal to the 2 pi third, and be done. Any question? When it's a negative, make sure that be careful. So that is part B. Any question? Part C. You have 3 cases: sine, cosine, tangent. We give 1 from each. So the next one is sine inverse of negative radical 2. It's a negative number, it's a red flag. Okay. Solution. The definition first: sine inverse of negative radical 3 equal to the theta. So that gives you the sine of the theta to be equal to the negative radical 3 and the theta between negative pi half and the pi half. Okay, negative radical 3. What's wrong with this one? Can you have an angle whose sine is negative radical 3?
No.
No. Because you know that the sine is always between negative 1 and positive 1. So this is negative radical 3, which is negative 1.7, so it's impossible. Okay, so you got to be careful. The sign, you see, remember the range of the sign? Sign must be between -1 and +1. So you have negative radical 3, which is outside of that. You see, this is a -1, and this is a +1. Okay, a +1. So this is negative radical 3. So this would be impossible.
Impossible.
It's impossible. You say, but the sign of any angle must be between a +1 and a -1. So sine of theta equal to the, okay, no solution. Sine of negative radical 3, it does not exist. Does not exist. So be careful in the case of the sine and the cosine. Sometimes they give you something quickly. So check this one. It's a -1.7. -1.7 is outside of -1 and 1. So it's impossible to find an angle whose sine is equal to the negative radical 3. Any question? It can happen for the sine or a cosine, okay? And you have one more again when we go on. So sometimes, they drop one of these just to check to see if you can, if you remember it. Any question? So that's a part C. Part D again, let's just repeat there. These are the one that we call it type 1. So you get one of these as one question, but it's a couple of parts. So you want to find the sine inverse, okay? You want to find the sine inverse of negative radical 3 over 2. Okay, it can be done. You want to find an angle whose sine is negative radical 3 over 2. It's a negative number, red flag. Be careful. Okay, so you let the sine inverse of negative radical 3, okay, have to be equal to the theta. You switch it. It's a sine of theta equal to the negative radical 3 over 2. And remind yourself that your theta must be what? Must be between negative pi half and the pi half. Okay, since it's a negative, you see, since it's a negative, you know that this is going to be a negative pi half. Okay, this is negative pi
Third
half.
or fourth.
That's it,
Okay.
yeah. So it must be here.
Yes.
Okay, you check. Sine of the theta, radical 3 over 2. For the radical 3 over 2, you know that this is the sine of 60 degrees. So if you're going to be here, it's a 60 degrees, which is pi third. Since it's a negative, you have to go to this side. Negative pi third. Okay, the sine of the 60 degrees is radical 3 half, but you must be in the fourth quadrant and you must be between negative pi half and the pi half. You see, you can go to the third quadrant and you get it, but you cannot have it here, okay? So make sure that you write it down in this range. In this range, the theta is going to be equal to the negative pi third. So the sine inverse of a negative radical 3 half is equal to negative pi third. Any question? So the other option is, you see, the other option is 240, or the other option is 300. But remember, it's not correct because you must be in this domain.
Yes.
So pick a number that's going to be in that, in that domain. This is the only one that you have to be careful. Anytime it's a negative number, that's okay, that would be a red flag. Be careful. For the positive numbers, you don't have any difficulty. Okay, any question?
No.
This is the first group. We give you one question of this format. Okay, we call it the first group. Now what's going to be the second group? The second group is a combination of these trigonometric function. Okay, so we get one question, again, 2, 3 parts of this format. Let's start with the E. Okay, start with the E, and the E is a tan. Okay, it's going to be tangent of the cosine inverse of a negative half. This group would be divided in two parts. You see, you have a tangent of cosine inverse, there's going to be an inverse here. It's going to be two parts. The first part is these numbers are known. You can find it on the unit circle chart. But there's going to be another type that this number is unknown. Okay, so these are going to be the known one. So for the known one, the starting point is you just call this cosine inverse something, and then you work on this one. Okay, so you get the cosine inverse of negative half. Okay, cosine inverse of the
Data.
negative half to be your data. Okay, so you make all this one your data. Then you switch it. Okay, when you switch, that give you what?
Cosine data.
That give you cosine of the data is equal to the negative half. And remember that this data must be between
In the second quadrant.
second quadrant, 0 and pi. That's easy to find out. You can use your table to find it. And this is going to be, okay, what is cosine of 120, 2 pi third. You see, you need a negative half. This is a negative half, and that's a 2 pi third in the second quadrant. So this will tell you that the data, okay, so your data is going to be 2 pi third. Okay, any question? Now you go back and you substitute here, you get a tangent. Okay, when it's a known one, this is how we're going to do the second part. Okay, so you want to find the tangent of the 2 pi third. Okay, the tangent of 2 pi third in the second quadrant. So this is going to be negative, and this is going to be like the tangent of the 60 degrees. The tangent of the 60 degrees is radical 3. Okay, if you divide the sine and the cosine, you get the same one. But it's like the 60 degrees, 120, the leftover of the, okay, leftover of a 60. Okay, any question? So the final answer would be negative radical 3. Okay, when it's a known one, you will get something known here. Then you go back and you substitute, and you're just using the table again. Within that table that you have for the 30, 60, okay, that would be also useful for you. That is a part E. You have a combination of various format. Okay, for example, part F. Oh, part F is interesting. They ask for the secant. Okay, they ask for the secant of the sine inverse of radical 2 over 2.
Oh, yes.
But radical 2 over 2 is a well-known one.
We have to find cosine.
Yes, let's find the inside one first. Sine inverse of radical 2 over 2. We want to find an angle whose sine is radical 2 over 2. That's pi 4.
Pi 4.
You can
And
call it
cosine by
data.
4.
Yeah.
Cosine.
So it's the sine of the data, okay, is equal to the radical 2 over 2. That's easy. The data between negative. You don't have to write because that's a very popular one. We know it. But I explain it. So that give you your data equal to the pi 4. Okay. Now you go back and substitute here. So you were interested in the secant of the sine inverse of a radical 2 over 2. So you get the secant of the pi 4. You know that the secant is 1 over cosine. So it's going to be 1 over cosine of the pi 4. Cosine of the pi 4 is radical 2 over 2. So you flip it. So that gives you 2 over radical 2. Then you have to simplify it. So the secant of the sine inverse of the radical 2 over 2 is going to be what? It's a 2 over radical 2. It's going to be 2 radical 2 over 2, which is radical 2. So the secant of the sine inverse of radical 2 over 2 would be radical 2. Okay, so various format, but the original angle is known, so you get that one right away. So what's the question? That is, isn't that radical 3 over 3? Which one is it? Radical 2 over 3? No, it's not. Which one are you talking about? No, it's a radical 2 over 2. No. Okay, so this is going to be the case. Secant. Which one are you talking about? Part F? That's a part F. That's part F. Secant of the, okay, it's a secant of the sine inverse of the radical 2 over 2, the part F that I have. Okay, you have to find this one first, okay? From the canvas. What's that? It's different. I check that one. They're almost the same. Maybe the numbers are. Oh, from the canvas is a secant of the tan inverse. There must be. Okay, I do that one too. That's the one that I changed it recently, but I do that one too. The one in the canvas, this is another version, is okay, secant of the tan inverse of the radical 3 over 3. It's very similar to this one. I do that one too. Okay, let me just try
Yes.
that one too for you. So this is just I just get the original branch, change it. Okay, so let's try to put this one. So I don't want to shade it because otherwise I will lose this one. Okay, the one that I posted on the canvas seems to be different. So I do that one too. You see the other one is secant of the tan inverse, okay? Secant of the tan inverse of the radical 3 over 3. Okay, that's the one that you have on that new version
Yes.
that I put over there. Okay, it's the same thing. Okay, so we start with this one. So we start with the fact that the tan inverse of radical 3 over 3, we call it theta. Okay, we switch. So that gives us a tangent of the theta equal to the radical 3 over 3. And you want it between pi half and the pi half. Okay, it's positive number. The tangent, you know that this is going to be what? Is it 30 degrees? Because the tangent of the 30 degrees, so the theta is going to be equal to the pi 6, okay, which is going to be 30 degrees. So we go back and we substitute. So what we have now is a secant of the tan inverse of radical 3 over 3. Now we change it to the secant of the pi 6. Okay, is going to be 1 over cosine of the pi 6. The cosine of the pi 6 is going to be radical 3 over 3. Okay, it's a 30 degrees, and the cosine of the 30 degrees is going to be radical 3 over 2. So it's going to be 2 over radical 3. And you rationalize it. It's a 2 radical 3 over 3. Okay, so if this is going to be that version, that would be the solution. Okay. So that give you, okay, that give you the final answer. In both cases, we arrive at, this is the way we're going to operate it. Okay, so we continue. with those numbers. Okay, any question? So just going back again to my notes, get these numbers. Okay, so this is it. Any question? No, there are quite a lot. Let's do one more to get to the, that was the, that is the, you know, the type 2 that we talk about it, but everything was well known. Okay, so we get one, you know, we just put a couple of them together. But the situation is going to be sometimes these angles are not going to be known one, and you are not going to use your calculator. So that's going to be part G. And you will study. I put a take on one for you as well for this test. Okay, give you some idea, so you get a chance to practice again. So you want to find the cosine of the sine inverse. Okay, the sine inverse of the 3/5 of the 3/5. So as you can see, the 3/5 is not a known one. So that's why it takes a little bit more time to do it, but it's not bad. Okay, so what we're going to do, we are going to start with the data. So we're going to take the sine inverse of the 3/5. Okay, sine inverse of the 3/5 is going to be theta. Okay, so the sine of the data would be 3/5. And the restriction, the data is between -pi half and the pi half. Now we know that we are going to be in the first quadrant because it's positive. Okay, so you are here. Okay, because you want to find the cosine. Okay, so what we are going to be interested in. So now the cosine of the sine inverse of the 3/5, okay, would be changed into the cosine of the data. Now it's easy to find. You get the right triangle to get the cosine right away, okay? So you have the sine. Sine of the data is equal to the 3/5. Get a right triangle. This is going to be your data. You have the sine, which is going to be 3, and this is going to be 5. 25 minus 9, 16. So that would be 4. Okay, so you want to find the cosine of data. So the cosine of data would be what? Would be 4/5. Okay, so the answer is, so the cosine of the sine inverse of the 3/5 is equal to the 4/5. And we're done. Okay, any question? So that's the other one that I talk about, you know, the other case. The case that is not known. So you have to, the second part, you have to go to your right triangle. Just make sure that, you know, you, with this property that you have, you see you are either in the first or the fourth, but since 3/5 is a positive number, so you are going to be here. So you're going to be here, and that will help you when you want to estimate the cosine. Okay, any question? It can come with some other okay terms. That's a question. Okay, to get these numbers. We use the right triangle when these numbers are not well known. You see, if you can find these numbers in your unit circle, you see it's going to be 1/2, radical 3/2, radical 2/2, that they are well known. But when you see the number which is not going to be in your unit circle chart, this is where you have to use the right triangle. Okay, this is how we divide in two parts: the part that we have to use the right triangle or otherwise. Okay, any question? So let's get another one of this format. Part H. I'm going to go to the next page because I need more rooms. Okay, so we go with the part H. Okay, what's the part H? Part H, I have tangent of a cosine inverse of the, okay, this is the tan of the cosine inverse Okay, cosine inverse of the negative 3/5. Okay, so this is what we have. So we just check, make sure we get the same one. Okay, so that's h, tangent of the cosine inverse. Again, you see negative 3/5 over here.
Yes.
Negative 3/5, so this means you have to use, okay? So this means we have to use the right triangle again for this one. So let's start with the middle one. And so this is it, the cosine inverse of negative 3/5. So we call it theta. So it's a cosine of the theta is equal to the negative 3/5. We remind ourselves that it must be between 0 and pi. The cosine is negative, so this means you are in the second quadrant. You are here. Okay, again, the number is not well known, negative 3/5. So we have to use the right triangle version. So just check to see what you are going to be interested in. So we change it into the, okay. So this means we are interested in the tangent of the data. Okay, tangent of the data. We have to take the right triangle. So this is it. The cosine of the data is equal to the negative 3/5. So we have this right triangle. Okay, this is it. So this is going to be your data. It's going to be adjacent. You can write 3 or negative 3, doesn't matter. Okay, because you know that you are in the second. And this is going to be 3. Okay, yes, I'm sorry. This is 5. 5. Okay, so this is going to be 25 minus 9, 16. So this is, okay, this is going to be 4. Now we are ready to give you the tangent. So the tangent of theta, the tangent is negative because we are in the second quadrant.
Negative 4/3.
Negative 4, 4/3. That's it. So the final answer, the tangent of the, you know, we don't have to rewrite it, but I rewrite to explain it. So that give a negative 4/3. Okay, so because this is not a known numbers, so we have to use the right triangle version to get this one. Okay, any question? So that is going to be the case. Now the next one is the known one. Okay, just getting back to the previous version because you know, it's the known angle. So we want to find sine inverse of the cosine of the 2 pi third. Okay, cosine of the 2 pi third. Okay, so this is going to be the case. 2 pi third is the known angle, and we can easily take care of it. Okay, this is 120. We go to the table and we find it. So the cosine of 2 pi third, 120 table, the cosine is negative, so it's going to be negative half. Okay, you have your units circle one, and you get it right away. 2 pi third is negative 1/2. Okay, so you go back and you put it here. So this means you are interested in sine inverse of, okay, sine inverse of 1/2. Okay, you substitute. So we start from here. You can get it right away. You want to find an angle.
The negative,
Oh,
Professor?
Negative.
Okay.
yes. So this is it. So it's a sine inverse of negative half equal to the theta. So you want to find the sine of the theta equal to the negative 1/2, and you are going to be in this range.
Yes.
Okay, now you know that it's a negative. Since it's a negative, you are not going to go to the third quadrant.
No.
You are going to be on the fourth. Okay, so you are here. So for the positive, 1/2 is the sine of the third degree, is pi 6. So for the negative, you get negative pi 6. Okay, just make sure don't miss it when it's a sign of the tangent. Okay, so it's a negative 1/2. We are not going to go to the third quadrant. We are not going to write it down anything greater than the pi half. So we have to use the negative angles. So in this case, the data is going to be negative, okay, negative pi 6. Okay, so the sine inverse of the cosine of the 2 pi third is a negative pi 6. Okay, again, it's a known one, but they intentionally they give you a negative number. They want to know if the final answer, are you going to write it down in the form of the negative pi 6 or something else. So be careful. Okay, any question? So the part J is similar to this one again. Okay, the part J. So you have a cosine inverse. Okay, cosine inverse of the cosine of the 7 pi 6. Some people quickly, they write this one as 7 pi 6, but you better check it. Because they say cosine inverse cosine, it's like they cancel out each other, they give 7 pi 6. But it's not going to be always the case. It depends on the angle inside. So
it is like cosine pi over 6.
yeah, you have to, yes. If it's going to be
Reference, I think.
yeah, it's a 7 pi 6, then you may be surprised. Okay, so what we do, we just double check it. Cosine of the 7 pi 6. Okay, 7 pi 6 is going to be what? Is in the third quadrant. So it's a negative
-3/2. Negative rad 3/2.
That's it, 3/2. Since it's a negative, then you got to be careful, but it's a cosine. It would be fine. So you have to find this one. Okay. Since it's a cosine, so the cosine inverse of a negative radical 3/2 equal to the theta. So this means the cosine of the theta, you want it to be negative radical 3/2. You see, since it's a cosine, you know that you are going to be between 0 and pi. You are in the second quadrant in this case. Okay, because you want it to be negative and you got to be in this interval. So you have to be here. Okay, so if you want to be here, so this is going to be what? If you check the table, so that should give you what? 150 degrees.
5 pi over 6.
5 pi over 6, yes. 5 pi over 6. 5 pi over 6. You see, so you got to be careful. That was a 7 pi 6, but you didn't get the 7 pi 6 as you expected. And so the cosine inverse of the, because you get that negative number here. And so this is it, so the final answer. So check it, you see, don't go with any theorem. Check to make sure that you get the correct answer. So it's going to be, okay, 5 by 6. If it's going to be anything in the, okay, in the first or the second quadrant, they will cancel out to get the same answer. But that gives you something in the third quadrant. That was why you get two different numbers. You see, if it's get cosine inverse of the cosine of the pi 4 is pi 4. Okay, the cosine inverse of the cosine of the 2 pi third is 2 pi third. But not anything over. So that was 7 pi 6. It's over of the pi. You see, so that's why you make a different answer. So you got to be careful. Just check it. Okay, check it to get these numbers. They give you with the sign, so you will see one of them because they want to check to see how you operate with this one. Any question?
No.
We have it with the sign. Okay, let's check the part K. Okay, for the part K, this is what we have. Just check, make sure you get it right. Oh, in the part K that you have is with the tangent. I check it. Mine is the sine, so go with the tangent. Sine and the tangent is both of them are going to be behaving like each other. You say tan inverse of the 10 of the 7 pi 6. So we want to know what would happen to this one. Are you going to, again, a kind of canceling out this or not?
Mhm.
Okay, so you better check it. The tangent of the 7 pi 6, 7 pi 6 in the third quadrant. So the tangent is going to be positive, and it's the
Yes.
same as the pi 6. Okay, so the solution is going to be the tangent of the 7 pi 6 is the same as the tangent of the pi 6. Okay, the tangent of the pi 6, which is 30 degrees, would be radical 3 over 3. Okay, 7 pi 6 in the third quadrant. You see, this is it. You are here. The tangent is positive. And the tangent of 7 pi 6 is the same as the tangent of the pi 6. Now we go back. So tangent inverse of the tangent of 7 pi 6. Now it would be changed into the tangent inverse of radical 3 over 3. So we would like to find a, okay, you would like to find an angle whose tangent is radical 3 over 3. That angle is 30 degrees. Okay, you can call it theta if you like. You may call it theta, and the tangent of the theta is going to be radical 3 over 3. And you know the condition is that you must be between the pi half and the pi half. It's positive, you know, you can answer it quickly. So the theta in this case is going to be 30 degrees. Okay, bring that paper that we give you at the beginning for the 30, 60. You need that one for most of these numbers here. Okay, so this means that the tan inverse, okay, the tan inverse of the tangent of the 7 pi 6 is equal to the pi 6, you see? So you have to check this, okay? Don't memorize any formula. You have to check it, and also that you are not going to be, okay, not going to be surprised. Okay, so that is part K. Any question? And the part L is, okay, just getting back to the one that we did before. So you have quite a lot really. If you practice this, you don't need anything else. You have all the possibilities. So you want to check this one, the recorder. Okay, that's again, the number inside is not known. So this means you have to use the right triangle version to get this one. Okay, if the number is going to be known, you need circle. If it's going to be unknown, then you have to go with the, okay, the right triangle. So again, start with the tan inverse of 3/4. Call it theta, switch. It's going to be tan of theta equal to the 3/4 with the condition that the theta is between negative pi half and the pi half. Since it's a positive, this means you are in the first quadrant. Okay, you are here. Any question? So the number is not known. So we use the right triangle version, because if you go back and substitute, so this means you are interested in the sign, you see. So the sine of the tan inverse of the 3/4 would be changed into the sine of the theta. So it's like we have the tangent, we want to find the sine. So what we're going to do is we are going to use the tangent. Everything is positive, so nothing to worry about. We get the right triangle. So this is going to be the theta, tangent, 3, 4. Okay, 9 and 16.
Two,
5.
5.
5.
And you want to find the sign. Okay, and the
3
sign
fifths.
is going to be 3/5. That's it. So you're done. Okay, just rewrite it. So the sine of the tangent inverse of 3/4, okay, is going to be 3/5. And then we're done. Okay, any question? So we have all the possibilities. Okay, here, and that last one is again the tricky one, part M. Put it over here. You want to find the sine inverse of 1.0003.
Oh,
You want to find an angle whose sine is 1.003. Is it possible?
from calculator.
No, you can't do it. You say it's not possible.
Is greater than 1, right?
Greater
So
than 1, yes. So it's not possible. So you can call it, if you like, sine inverse of 1.003. You may call it theta. So the sine of the theta to be equal to the 1.003 is not possible. It's bigger than 1. Does not exist.
Oh, yes.
Because you know that the sine and the cosine at most is equal to 1. So it's a bigger than 1, like the other one that we did have. Remember, it was negative radical 3. That was negative 1.7, which is not possible. So be careful. They usually put some of these in one of the choices that you have. So
Oh,
write
yes.
it down. But even if you use your calculator, the calculator give you an error because this is not going to be possible. Okay, so this is any question? So this is, as you can see, all the possibilities. All the possibilities, we put them usually into 2 questions. Each question would have a couple of parts, and then we ask you to give us the final answer. Now, there are 2 more questions regarding this group. I do number 7 first. Okay, number 7 is interesting, and we use it sometimes. Number 7 is a combination of this inverse trigonometric function that we talk about it, and the formula for the sum or the difference of 2 angles. So this is number 7. It's a very popular problem. We give you one of them. Okay, we want to find the exact value. Use no calculator. Find the exact value of each expression. We have 2 here. The first one is you want to find the sine. Okay. You want to find that is it. Let's check it. Yes, I don't have any other version. So it's the sine of the cosine inverse. Sine of the cosine inverse of 5/13. Okay, minus the cosine inverse. The cosine inverse of 4/5. Okay, this is going to be 1. It can come with the sine and the cosine. Okay, 2 possibilities. We may give you one of them, or we may give you both of them. Now, the idea of this type of problems is without calculator. So you have to quickly take care of these inverse, remember? So you have to quickly take care of this inverse. You have 2 different ones. So you have to call this one, for example, alpha, and the second one beta, because you want to use 2. If you call this alpha and the beta, then you have to find the sine of alpha minus beta, you see? Sine of alpha minus beta, you know that that's a sine of difference of 2 functions. Then you have to distribute it and substitute to get the numbers. Okay, it takes a little bit of time, but it's not bad. It has, the starting point. So you have to pick 2 variables, if you like. Suppose you're going to pick the cosine inverse of 5/13 to be equal to the alpha, and the cosine inverse of 4/5 to be equal to the beta. Okay, so you have to pick 2 variables, if you like. Suppose you're going to pick the cosine inverse of 5/13 to be equal to the alpha, and the cosine inverse of 4/5 to be equal to the beta. Okay, so you have to pick 2 Okay, quickly, you know what does it mean? This means the cosine of alpha is equal to the 5 over 13. And remind yourself that your alpha is going to be between 0 and pi. So this means alpha is in the first quadrant because the cosine is positive. Okay, make a note because you need it. So the alpha is here. Okay, you have to pick something else for the second one. So the second one is the cosine inverse of 4/5. Okay, you are going to call this one something beta.
Wow.
Then you switch, that give you cosine of beta equal to the 4/5, the same condition. So this must be between, okay, 0 and pi. So since it's positive, so this must be in the first quadrant, okay? So this would be very, very useful. We must know it, okay? Now we go back to the question. We say, oh, the question would be changed into, you see, this question would be changed into the what? Would be changed into the, what is the sign of alpha minus beta? You see, that's the case. So we have to find the difference between the signs. You know that before. Yeah, we know that's it. Yeah. So we know the formula. Bring all those formulas to the test. We don't mind. Okay, so this is going to be the sine of the alpha, cosine of the beta, minus cosine of the alpha, sine of the beta. So before going on, we have to go and find it. We have the cosine of the alpha, it's the first quadrant. We have to find the sine of the alpha and the sine of the beta. Then we come back and we substitute, okay? It's kind of a complete problem, really. Check everything for us. So that's why we like it. Okay, so let's start with the cosine of the alpha, which is 5 over 13. So we get the right triangle. So this is going to be your alpha. And you have a cosine, so this is going to be cosine. And that would be 169 minus 25, 144. So that gives you 12.
12.
Okay, that would be 12. And then you need to find the sine in this case. So the sine of the alpha would be 12 over 30. Okay, so we have all the information for the sine for the alpha. Any question?
No.
Check the other one. So we check the beta, cosine of the beta is equal to the 4/5. So we get the right triangle for this one. So that would be our beta. We have the cosine, so it's going to be 4/5. Now it's going to be 25 minus 16, 9. So this would be 3. Okay, this would be 3. So the cosine of the beta is going to be 4/5. I'm sorry, I need the sine of the beta. Sine of the beta, sorry. So I need the sine of the beta. So it's going to be 3/5.
Yes.
Okay, now we have all the information that we need. We go back and we substitute. So the sine of alpha minus beta is equal to, sine of alpha is 12 over 13 times the cosine of the beta, which is 4/5, minus cosine of the alpha, which is 5 over 13, okay, times the sine of the beta, which is 3 over 5. Okay, so this is going to be 48 on the top, 65 down the bottom. Okay, minus, and that gives you 15, and that's going to be 65. So subtract the top, 65, and that gives you 33. Okay, so that's it. So the sine of alpha minus beta is going to be 33 over 65, which is the final answer. Okay, as you can see, this is It's nice because you use everything you know,
Yes, very nice.
everything you know to get these numbers. Takes times, but it's not bad. We give you one of them. Okay, the other one is cosine. We can check it quickly so that we have all of them here. Okay, so it's it's usually one of them. So the second one is a combination. Are you done with this one? So the second part, 7b. 7b, they switch those inside one. So we would like to find what is cosine. Okay, what's going to be the cosine of the sine inverse? Cosine of the sine inverse of the 3/5. Okay, 3/5 minus cosine inverse of the half. Okay, this is going to be the case this time to get these numbers. Again, same thing. The inside one, we're going to check them to be alpha, beta. This time they are different, doesn't matter. You have the sine and the cosine. The important part is the outside.
Yes.
Okay, so you are going to start with calling sine inverse of the 3/5. You are going to call it alpha. So that gives you the sine of the alpha is equal to the 3/5. And the restriction is the alpha between negative pi half and the pi half. So that will tell you that you are in the first quadrant again, because the sign is positive.
Mhm.
Okay, that's going to be the case. And you are going to pick the second one. So the second one, you have to start with the cosine. So the cosine inverse of the 1/2, you call it beta. So that will tell you that the cosine of the beta is equal to the half, with the restriction that the beta is between 0 and pi. So this means you are again in the first quadrant. These are going to be useful even if you don't write it down. You must know where you are, okay, to get these numbers. So again, the same thing. The question now this time would be changed into cosine of. Okay, it's going to be the cosine of the
Alpha.
alpha minus beta. Okay, we know the formula, so we need the sine of the,
Cosine alpha.
oh, the other one, yes, we need the cosine of the alpha and the sine of the beta. So we are going to prepare those formula first.
Yes.
So we have the sine of the alpha, which is a 3/5. Okay, we get the right triangle. This is going to be our alpha, the opposite adjacent. So that gives 25 minus 9, which is 16. So we get a 4 here. Okay, so we're going to be interested in cosine of the alpha, which is going to be 4/5. Okay, this is going to be for alpha.
Mhm.
Okay, we have to repeat it to get the beta. For the beta, we have the cosine of the beta. So the cosine of the beta is 1/2. Okay, so get the right triangle for this one. So this is going to be your beta. So we have the cosine, so it's going to be 1, and this is going to be 2. So that gives you 4 minus, that's a well-known one, but we just find it. You know that this is cosine of the 60 degrees. But anyway, that's going to be 3. That's going to be radical 3. So, if you recognize it, you can write it down, but we find it. It's a 60 degrees. The sign is radical 3/2. Okay, now we are ready to distribute the formula and get your result. Okay, this is it. We are interested in the cosine of the alpha minus beta, which is going to be cosine of alpha, cosine of beta, but plus sine of alpha, sine of beta. Substitute. Cosine of alpha is 4/5. Okay, that's a 4/5 times a cosine of the beta, which is 1/2. Okay, plus sine of alpha, which is 3/5. Okay, sine of beta, which is radical 3/2. So the first one is going to be, don't simplify it, just keep it because you have to find the common denominator. Okay, 410. And this is going to be 3 radical 3. Okay, over 10. So the result would be 10 over 4 plus 3 radical 3. You cannot simplify it. So that would be the final answer. Okay, cosine of alpha minus beta is 4 plus 3 radical 3 over 10, the final answer. Okay, so that's a very popular problem. It must be given. I think you have 1 or 2 in your book. I'm not quite sure about it. But when we teach pre-calculus, this is one of those problems that we investigated, and it's going to be used, not in general, but not bad. We get all the information that we need. Okay, any question?
No.
Now, there is one that we use in calculus that would be different. Okay, but not bad. Get to know these type of ideas. Okay, now what is going to be the idea is you see in this problem, these problems that we did have something very mild before of this format. In this problem, everything was given to you in terms of the numbers. But when you are going to be in calculus, you like functions. So you may have, you do the same thing, but not with the number, with the x that give you, that your function. So would like you to get a little bit of those ideas for future. So we are very much again interested in to give you one. So that would be number 5. This type of ideas is used in calculus 2, if you want. Okay, just continuing and getting these type of courses. So that's a main reason really that you study these type of ideas. Now, again, the one that I have is a little bit different. So I do, I go with this one. You see, we want to write each these expressions in terms of the x, okay? It seems to be complicated. So what you are going to do with this when you get to the application problems? Okay, we would like to write each expression, okay, these are trigonometric expression, okay? Trigonometric expression, metric expressions. Okay, we want to write it as a function of x, as let's say algebraic expression, and they mean function, algebraic expression in x. We want to remove these sine inverse, cosine inverse, etc. Okay, so that's the idea of these type of problems. And the part one is the sine of the tangent inverse of x. You see, you did it with the numbers. You did it with the 2, 3s. But how about if you deal with the formulas? Okay, use the same method. The same method that we did. So in this case, you are not going to have numbers. So everything would be in terms of the x. And at the end, you create a formula for us, okay? A sine of the tangent inverse. What we do with this type of problems is we do something else. We call it substitution method when we apply these type of methods. We start with the x. We change it to the trigonometric function. We do the job. But when we do the job, the result would be this format. Then they tell you that, oh, we didn't have any trigonometric function. So why you did arrive at this type of formulas? Okay, so that's why they wanted to simplify your results. that is going to be the 1. Okay, that's the reason. So there is an x at the end, you get it. Oh, so you just go on as you did for with the other one. You know that you start with the middle one. Okay, you are going to suppose same thing. Suppose your tangent inverse of x is equal to the data, for example. Okay, you switch it as we did it for the other one. So if you switch, that give a tangent of theta is equal to the x. Restriction, the data is between negative pi half, okay, and the pi half. That is going to be the situation we're going to have. Okay, so they may give you some idea for the x, whether x is positive or negative, but they didn't say anything. Let's see if we need it. So what we are going to do is, so what we need is this one. So we are interested in the sign of the tan inverse. Okay, tan inverse of x, then it would change to the sign of the data as we did it for the other ones. So what we can do, you can use the right triangle version, okay, to get these numbers. So what you are going to do is we say, oh, the tangent of the data is equal to the x. I can think about it as x over 1. Okay, so that gives me my right triangle. Okay, this is going to be my right triangle. So this is going to be the data. So I have the tangent. The tangent is what? Is the opposite adjacent one. So this portion over here is what? It's x squared plus 1, but you have to take the square root. So it's going to be a square root of 1 plus x squared. Any question? So you are not going to get the number. You have to get everything in terms of the x. So Pythagorean identity that give you x squared plus 1, x squared plus 1, you have to take the square root to get to that 1 plus x squared. Now we can find you can find the sign. What is going to be the sign? So the sign of the data is going to be what? Is going to be the
X
opposite.
over rad 1 plus x squared.
That's it. So if you go back and what you did is you have the sign of the tan inverse of x, which is complicated, but in terms of the x is simply x over radical 1 plus x squared. You see, that is what they mean with this type of operations. As I told you, when you deal with this problem in calculus, to start, the problem is of this format, if you like. You do something else, you want to do something, we call it integrations. We want to get rid of the radicals. We say, oh, we are going to use trig substitution. But when you simplify everything at the end, they say, oh, what is this? Sine of the tan inverse of x doesn't make sense. Change it to the, okay, change it to the x. So that's the extra job, extra algebra that you have to do. Okay, what's that? Can that be simplified to x radical? No, no, no. You don't do. You're not going to do anything about it. You don't have to. If you mean to just multiply the top and the bottom into the 1 plus the radical x squared. No, you ask for can be simplified to the x radical 1 minus x squared. No, we don't simplify it. That is going to be the case. You may try to rationalize it. No, the idea is just switch it to this, to this type of function for future applications. That we just want the expression in x, and we got it. Okay, so that's the idea. It's very important one. When we get to the calculus, some people are lazy. They write sine tan inverse of x. In some books, even they accept this one as a solution. But when we teach, we say, oh no. So you have to know it. You have to get back and give us a better, better format of the solutions. Okay, so we want to see what is going to be the real application of these ideas. So most of them are the same. So I give you another one, a part B. That was part one. Just to know it a little bit. So the part one is the tangent of the cosine inverse of x. Okay, this inverse of the trigonometric function would have many applications really. These are very useful. So it's the same thing, okay? We start with the cosine, okay? So the solution is going to be, you are going to suppose a cosine inverse of x to be equal to the theta. Then you switch it. So that give you cosine of the theta is equal to the x. And as usual, your theta is going to be between 0 and pi. Okay. And so your question now is going to be, so the tan of the cosine inverse of x would be changed into what? It's going to be simply changed to the tan of theta. Okay, so it's the other way around. And so you are going to build up that right triangle. Cosine of theta is equal to the x. You may think about it as x over 1. So you can get a right triangle. Okay, this is going to be the right triangle. And this is your theta. So it's going to be adjacent one, which is the x. And this is 1. Now you have to define this one this time. Okay, which is going to be a square root of, you see, this is going to be, is 1 squared minus x, okay? 1 minus x squared, 1 minus the root of the 1 minus x squared. Okay, you know that it's going to be particular identity. 1 squared minus x squared would be 1 minus x squared. You take the square root. So we are ready to give you the tangent. So the tangent of theta is going to be the opposite, which is radical 1 minus x squared, and this is going to be x, and then you're done. Okay, any question? It's using calculus 2, not calculus 1, quite a lot. Okay, if you want to take these courses, calculus 1, 2, calculus 2 is very heavy course. And there is one chapter regarding to trigonometric function, and you apply everything I'll talk about it tonight, okay, on that sections. That's why some people feel uncomfortable on that sections, but you are going to be ready for it. But otherwise, in general, it's a nice function. Okay, so these are the one with the trigonometric function that we did. Any question? Now, the rest are going to be like your quiz. Okay, so I do number 6 for you again. We give you just a sine and a cosine. We ask for the double angle, remember? As you did on the quiz, sine of 2 alpha, cosine of 2 alpha, we repeat it again. Then a difference and the sum, we repeat it again, but you have something extra, that's a half angle. So I explained the half angle from number 6. Everything else is the one that we did on the quiz. Okay, so number 6 in this form would be question. Okay, so the question is going to be, suppose sine of alpha is given to you. You see the sine of alpha is equal to the 4/5. Okay, that's a 4/5. And the alpha is between 0 and pi half, first quadrant. And we have the sine of the beta. The sine of the beta is equal to the 5/13. Okay, and beta is in the second quadrant. Okay, so we want to find the exact value of this. Find the exact value of your new problem is this one. Part E, you didn't have this one before. You want to find the sine of alpha half. Okay, part F is going to be cosine of the beta half angle. So for the double angle, be ready for it. We repeat it again. For the sum and the difference of the angles, be ready for it. It's the same question, similar question on the quiz. But this half angle, this is going to be a new problem. We give you one, and we ask you these two together. And remember, the way we are going to do it, we are going to use that power reducing formula. The power reducing formula was that if you have a sine square or a cosine square, you reduce the power, but pay for it. How are we going to pay for it? Double angle. So this is going to be the situation we're going to have. Solution. Part E. You start with the sine squared. Sine square of the alpha half. Now the power reducing formula. It's a 1, it's a sine minus cosine of the double angle. This is half, the double would be the angle, divided by 2. That's it. Okay, sine square of the alpha half is 1 minus cosine of alpha minus 2. Then you find it first, then you take the square root. So that would be for the sine. For the cosine, you know that this would be 1 plus. That's it. But the difficulty is that you need the cosine of alpha, but the sine of the alpha is given to you. It's always the case. So we have to find it first. Okay, so what we're going to do is we take the sine of the alpha is equal to the 4/5 in the first quadrant. Okay, so get a right triangle. This is going to be your alpha. Okay, this is going to be your alpha. So we have the sine, the opposite, hypotenuse. Okay, so this is going to be 25 minus 16, 9. So this would be 3. Any question? So it's question. So it's a cosine of alpha. It's in the first quadrant. So that gives you 3/5. Okay, go back and substitute. Okay, that's it. Cosine of alpha would be 3/5. Okay, now we go back. So we have the sine square of alpha half is going to be equal to 1 minus cosine of alpha, which is 3/5. 3/5 over 2. Simplify on the top. It's like 5/5. 5 minus 3,
Yes.
so that gives you 2. 2/5, and this is 2, 2 over 1. So write the top, multiply by the reciprocal of the bottom. So half 2 and 2 would be out, so that gives you 1/5. Okay, so the sine inverse, sine square of alpha half, sine square of alpha half would be 1/5. Take the square root. So sine of alpha half would be positive negative. Radical 1/5. We put the radical on the top and the bottom. On the top would be 1. 1 over radical 5th. And you multiply by the radical 5th. That would be radical 5th over 5. But the question is, are you going to get the positive or the negative?
Yes,
So
we have to divide.
that's it. You go say, oh,
Yes.
note that your alpha is between 0 and pi half. It's in the first quadrant.
But this is,
You
yes.
divide by 2,
So, yes.
0, alpha half, pi 4. So alpha half is between 0 and 45 degrees. So alpha half is in the first quadrant. And the sign is positive. Okay, so the sign of alpha half is positive. So the correct answer is positive, radical 5/5. You have to check this one all the time because it's going to be a positive negative one to get these numbers. Okay, any question? So make sure to use, the formula is unique, that's it, sine squared. Make a note of your formula, 1 minus cosine of alpha over 2. The only thing is this, that's the last part. When you find this cosine, be careful, it's going to be a positive sign, negative sign. But the alpha was in the first quadrant, so we didn't bother about the signs. Substitute, simplify it, go with the positive negative first, then you decide which one is it. Is it the positive or is it going to be negative? In this case, you get your alpha, whatever it is, divided by 2, everything divided by 2, 0 divided by 2 would be 0. That give alpha half, and that give 45 degrees. So alpha half is in the first quadrant because it's between 0 and pi 4. Okay, that's first part. Any question?
No.
Now the second part. You want to find the cosine of beta half, you have to do the same thing. The cosine of beta half would be 1 plus. Okay, so we start with that power reducing formula again. Okay, so that's a solution for part F. So we start with the cosine squared. Okay, cosine square of the beta half. So it's going to be 1, since it's cosine plus cosine of double angle. This is half, you multiply by 2, that give you beta, divided by 2. Okay, so that's going to be your formula. You have to find the cosine of the beta, but you'll be given the sine of the beta. Okay, so the sine of the beta is given to you. Okay, so we have the sine of the beta, which is 5 over 13, and the beta is in the second quadrant. 5 over 13. Okay, and the beta is
In the second.
in the second quadrant. So it's here. Okay, so the cosine is negative. So get the right triangle. Okay, we have the beta here. So the opposite over the hypotenuse. So that would be 169, 25 out, that give 144. So that would be 12. Okay, so we want to find the cosine. Cosine of beta, we know that the cosine is
I have a
negative.
question, Professor.
Yes.
How did you see it's in the second quadrant again?
You see, because it's given to you. The beta was given. Okay, the beta
Okay.
is between the pi half and the, that's given to us, okay?
The second one.
The second, yeah. So the cosine is negative, so it's going to be negative. Adjacent is 12, the hypotenuse is 13, so it's a negative 12 over 13. Okay, any question? So now go back and substitute. We substitute here, so we're going to have a cosine squared. Okay, it's the cosine square of the beta half, which is going to be equal to the 1 plus cosine, that gives a negative 1 minus 12 over 13 divided by 2. So the top would be 13 minus 12, which is 1. So it's going to be 1 over 13 over 2 over 1. So that would be 1 over 13 times 2 over 1. So the cosine square of the beta half is going to be equal to the 2 over 13 this time. Okay, 2 over 13, you take the square root. So the cosine of the beta half is equal to the positive negative radical 2 13.
Wouldn't you
But-
multiply by 1/2, Professor? 1 over 13 times 1/2.
Oh, yes, we are right. Thank you.
Yeah.
1/2, thank you. So it's going to be 26. Thanks. That's a 1 over 26. It's a 1 over 26. Okay, 1 over 26. And so this is going to be 1. Okay, so we get a positive negative, a square root of 1 over 26. So we go on the top and the bottom, radical 1 and radical 26. So the radical 1 would be just 1. That's a radical 26. You have to rationalize it. So the cosine of beta half is going to be equal to the positive negative. Okay, radical 26 over 26. But the question is whether it's going to be a positive or negative. So you have to check. Okay, you check the beta. Beta is in the second quadrant. You divide it by 2. So that gives you pi 4. This would be pi half. And this would be pi 2. So you get back to the first quadrant. Okay, because the original one is between 90 and 180. You divide by 2, that gives 45 and 90. So you are in the first quadrant, and so the cosine of beta is positive. So this means the final answer, the correct answer, is radical 26 over 26. Okay, so again, interesting case. So that's all things that we did new. Everything else is your quiz. So you have to study your quiz plus the one that I did today. So that make it to the 11 questions, okay, for that test. I post a take-home one for you. Okay, that would be good. You can bring it for the 2 points, and that give you the idea. It's going to be 11 questions. The model of the test, if you like. So we can check it, and then we give you the test. We have one more very important section of this chapter, and that's solving the equations, which is very, very interesting and very useful for future applications. Then the main part of the course will be out. There are a couple of sections in chapter 7 that we cover before the final, but this part is very important part. So just make sure you get it all right. Okay, any question? So the next week, we have no class next week, but I'll be available if you email me any question you have, because I have a class at the university. We have a spring break over there this week. So I'll be available. You can email me if you have any question, even any solution you wanted to check, okay? And I'll post the take-home one. Any question on that take-home one, I'll be happy to answer it. Okay, get a good one on this test. Yes, question.
Teacher, we have 7 questions in the test plus the question in the quiz, you mean? Because I see only 7 questions.
No, we give you, no, it's a 7 question, but give you 11 questions on the test.
I didn't see 11 you posted. I saw only 7.
Of course, it was 7, but it was very dense.
Yes, plus the quiz, yes.
Yeah, but I said I will post the take-home one. When I post the take-home one, then you have 11 questions.
Oh, second one.
Yeah, because one of these problems, remember that number like 5, 6, you have so many possibilities. This is the last one that I did. It's a 3 question from this one. 1 question, you get the double angle, like in your quiz, sine of 2 alpha, cosine of 2 alpha. 1 question, you get the difference and the sum of the angle, and 1 question, half angle. So that make into the 3 questions just from this last number. So I'll post a model for you so you can see it. It's going to be your take-home one. So that would be useful to give you 2 points, 2 extra points, and would be useful for you for the test. Okay, study your quiz and this one, then go for that take-home one, and you should be fine. That
Professor,
would be, yes.
On the test, is it going to be 11 questions, but only 10 will count again, or?
Yeah, that's good one. Yes.
Okay.
11 questions. Okay, remember it's going to be a test day, so no assignment would be collected. Nothing.
Yes, sure.
Just the take-home one if you want. No assignment. Don't send me anything.
Mhm.
Okay, it's just going to be a test day. Okay, so you have enough time, to prepare for it.
Mhm.
So if you have any question, just email me, and I'll be happy, to answer your questions. Okay, that's it. Any question?
No, teacher. Thank you so much.
Okay, have a
We
good one.
appreciate it.
Have a good one.
We wish
And
you to have good holiday also.
thank you. You too. Bye-bye. I'll check your quiz. If a couple of them was missing, I'll take care of it. Anything else, just email me. I will look all your points so far so that we have everything. Okay, I'll give you your points for your assignment, your take-home one, everything. So give me a couple of days, then send me an email if anything is missing. Okay, then I'll correct it for you. Okay, have a good one. Take care.
Same,
Bye-bye.
same
Have a,
to you.
have a
Thank
good
you.
Thanks.
break.
See you next time.
Okay, bye-bye.
See you soon, teacher.
Break. Okay, thank you.
Thank you.